Hey everyone, and welcome back for another deep dive. Today, we're going to be looking at how computers work.
Okay.
More specifically, we're going to be looking at input, output, and variables in computer programming.
Right.
And you might think that this is just for programmers, but it's really the secret language behind every app you use, every website you visit.
Yeah.
We're basing this deep dive on an episode of Code Curious,
Mm-hmm.
which is a podcast that does a really great job of explaining this stuff.
Yeah, it's really fascinating how these concepts underpin our entire digital world, you know?
Right.
It's like having a conversation with your computer.
Okay.
It's a back and forth exchange of information.
So let's break that conversation down.
Okay.
Code Curious uses the term input,
Mm-hmm.
which is like you speaking to the computer, giving it directions.
Right.
And they use the example of a program asking for your name.
Right. Asking for your name is a simple way to illustrate how input works. But remember, input goes far beyond typing. Every time you click a link, you tap your phone screen, or even speak to a voice assistant, you're sending input to a device.
That's a great point. So input is how we communicate our intentions to the computer.
Yes.
But how does the computer remember what we've told it?
Right.
That's where variables come in, right?
Exactly. Variables are like those little sticky notes that you use to jot down important information.
Okay.
In programming, variables are used to store data, so it can be accessed and manipulated.
So in that name example, the program would create a variable maybe called username.
Right.
And store what you typed in that variable.
Exactly.
But what's interesting is that the podcast mentions variables aren't fixed. Their values can change,
Mm-hmm.
which seems kind of different from how we usually think of variables in math.
Absolutely. Think of it like a container that can hold different things at different times.
Okay.
It might start with your name, but later in the program, it could hold your age, your location, or anything else the program needs to keep track of.
So it's not like variables are solving for X like in algebra. They're more like digital storage containers that adapt to whatever the program needs.
Exactly.
This is making me think of, those choose-your-own-adventure books.
Okay.
Where the story changes based on your decisions.
Right.
Are variables kind of like that?
That's a clever analogy.
Yeah.
Variables allow programs to respond dynamically to different inputs and situations, creating more interactive and personalized experience.
Okay.
Think about a navigation app.
Mm-hmm.
The variable for your destination might change every time you enter a new address, and the app recalculates the route based on that new input.
Okay. I'm starting to see how powerful variables can be.
Yeah.
So we've talked about giving the computer instructions with input
Right.
and storing information in variables, but how does the computer talk back to us? Is that where output comes in?
You got output is the computer's way of presenting the results of its calculations or actions.
Okay.
The Code Curious podcast mentions the print command as a simple way to display output, often combining it with the information stored in variables.
So instead of just seeing a generic message, the output can be customized based on the variables.
Exactly.
They give the example of a program that greets you by name,
Right.
using the information stored in the username variable.
Precisely. And this dynamic output is what makes our interaction with computers so engaging.
Yeah.
Whether it's displaying search results tailored to your query, showing personalized recommendations on a shopping site, or creating a customized workout plan based on your fitness tracker data.
Right.
Output is how the computer delivers information that's relevant to you.
This is all starting to click.
Yeah.
So we have input as our way of talking to the computer,
Yes.
variables acting as storage containers,
Right.
and output being how the computer communicates back to us.
Yes.
But I'm guessing there are rules about how all of this works together.
There are, and that's where syntax comes into play.
Okay.
Think of syntax as the grammar of programming languages.
Okay.
Just like a sentence needs proper punctuation and word order to be understood.
Yeah.
Code needs correct syntax for the computer to interpret it.
They mentioned syntax errors, which sound a bit scary.
Yeah.
Is that like when you forget a comma in a sentence and suddenly the whole thing doesn't make sense?
It's a good comparison.
Yeah.
Even a small syntax error, like a missing parentheses or a misspelled command, can prevent the entire program from running.
Wow.
It's like the computer hitting a roadblock because it doesn't understand what you're trying to tell it.
Okay.
And that's where Code Curious makes an important distinction between syntax rules, which are strict and must be followed,
Right.
and conventions.
Conventions.
Yes.
Are those more like guidelines than hard and fast rules?
Exactly. Conventions are best practices that programmers use to make their code more readable and organized.
Okay.
They don't affect the functionality of the program, but they make it much easier for humans to understand and work with the code.
Okay, so it's like the difference between following the rules of the road to avoid accidents
Right.
versus driving with good etiquette so everyone has a smoother experience.
That's a great way to put it. And just like learning good driving habits can make you a safer and more considerate driver,
Right.
following programming conventions can make you a better and more efficient coder.
All right, this is a lot to absorb,
Yeah.
but I'm already starting to see how these concepts are working together.
Good.
We've covered input variables, output syntax, and conventions, and it sounds like they all play a crucial role in how we interact with computers.
They do, and we've only just scratched the surface.
Wow!
What's remarkable is that these same principles are used to create everything from simple smartphone apps to complex artificial intelligence systems.
Okay, so this is definitely bigger than just writing a few lines of code.
Yes,
It's about understanding the fundamental building blocks of how technology works.
exactly. And as we delve deeper into this world, you'll see how these seemingly basic concepts can be combined in incredibly powerful and creative ways.
This is getting really exciting.
Yeah.
Before we move on, let's quickly recap what we've learned so far. We talked about input, which is like talking to the computer.
Right.
Variables, which are like storage containers for information.
Mm-hmm.
Output, which is how the computer talks back to us. Syntax, which is like the grammar of code.
Yes.
And conventions, which are best practices for writing clean and readable code.
A perfect summary. And now that we've laid the groundwork,
Yeah.
let's explore some real-world examples of how these concepts are used in the technology we use every day.
Okay.
You might be surprised to discover just how much of our digital world relies on these fundamental building blocks of programming.
This is going to be good.
It is.
All right, so we've got the basics down, input, output variables.
Right.
But the Code Curious episode keeps emphasizing how the value of a variable can change.
Mm-hmm.
I think we need to unpack that a bit more
Yeah.
because it feels like a key idea.
It is key. Imagine you're playing a video game and your score keeps increasing.
Okay.
That score is stored in a variable, and every time you earn points, the value of that variable is updated.
So it's like a variable is a scoreboard that
Wow.
keeps track of the game's progress.
Exactly.
But Code Curious also mentioned that variables can hold more than just numbers, right?
Absolutely. Variables are incredibly versatile.
Yeah.
They can store text images, sounds, and even more complex data structures.
Wow.
Think about a music streaming app.
Okay.
The current song you're listening to is likely stored in a variable, and as you skip to the next track,
Right.
that variable is updated to reflect the new song.
So the variable acts as a placeholder for whatever information is relevant at that moment.
Right.
But how does a programmer know what kind of information a variable should hold?
Right.
Is that where data types come in?
You're exactly right. Data types are like labels that tell the computer how to interpret the information stored in a variable.
Okay.
If you're working with numbers, you might use an integer data type for whole numbers,
Mm-hmm.
or a float data type for numbers with decimal points.
That makes sense. It's like choosing the right container for storing your belongings. You wouldn't put a gallon of milk in a tiny jewelry box.
Exactly.
Yeah.
And in programming,
Yeah.
using the wrong data type can lead to errors or unexpected results.
Right.
The podcast also mentioned something about naming conventions.
Yeah.
Is that related to data types?
Not directly, but it's another important aspect of writing good code.
Right.
Code Curious emphasized how choosing meaningful names for variables makes the code much easier to understand,
Yes.
especially for larger programs.
It's like writing a recipe with clear and descriptive instructions instead of using cryptic abbreviations.
Okay.
If your code is full of variables named X and Y, it becomes very difficult to figure out what's going on.
So instead of X, you might use a name like player score
Right.
or item price
Exactly.
to clearly indicate what the variable represents.
Yes.
They also mentioned camel case and snake case.
Mhm.
Are those different languages or something?
Not different languages, but different styles for formatting variable names.
Okay.
Camel case capitalizes the first letter of each word in the variable name, while snake case uses underscores to separate words.
Okay.
Python itself doesn't care which style you use, but being consistent makes your code more visually appealing and easier to read.
Okay, so it's more about readability and style than strict functionality.
Right.
But I'm guessing there are some rules that you absolutely have to follow in programming, right?
Yes.
Like with syntax and syntax errors, which we touched on earlier.
Absolutely. Syntax is the set of rules that govern how code is written.
Right.
And even a tiny syntax error can cause a program to crash. It's like trying to build a house with misaligned bricks or missing nails.
Okay.
The structure might look okay from a distance, but it won't be stable or functional.
So syntax errors are like those little red squiggly lines you get on a word processor when you make a spelling mistake.
That's a good way to think about it.
Yeah.
And just like a spell checker helps you write grammatically correct text,
Yeah.
there are tools in programming called debuggers that can help you find and fix syntax errors in your code.
They also mention that while syntax rules are essential, there's also room for personal style in programming,
Yes.
just like in writing. Is that what they meant by conventions?
Exactly. Conventions are best practices that help programmers write code that is not only functional, but also readable and maintainable.
Mm-hmm.
It's like the difference between writing a sloppy handwritten note and composing a well-organized email.
Okay.
Both can convey the same information, but one is much easier to understand and digest.
So conventions are like following the rules of grammar and punctuation to make your writing clear and easy to follow,
Yes.
even though you technically don't have to.
Right.
It's about making the code more human-friendly, right?
Precisely.
Right.
And as you learn more about programming, you'll discover a wide range of conventions that can help you write cleaner, more efficient, and more elegant code.
This is making me realize that programming isn't just about giving instructions to a computer.
Okay.
It's also about communicating with other humans who might read or work with your code.
Absolutely.
Yeah.
In many ways, programming is a collaborative effort,
Yeah.
and writing readable code is essential for effective teamwork.
Hmm.
It's like building a bridge.
Yeah.
You need to make sure that every part is structurally sound,
Yeah.
and that everyone involved understands the blueprint.
This is all starting to come together.
Good.
We've covered input, output variables, syntax, and conventions. And it's clear that these concepts are all interconnected. It's and
Yes.
essential for building functional and understandable programs.
Right.
But I'm curious to see how these ideas translate into the real world.
That's a great segue, because in the next part of our deep dive, we'll explore how these seemingly abstract concepts are used in the technology we interact with every day.
Okay.
You might be surprised to learn just how much of our digital world is built on these fundamental building blocks of programming.
Okay, so we've spent some time now unpacking these ideas and output variables, all
Right.
the rules that kind of go with them.
Yep.
But I think it's time to see these concepts in action, you know? Code Curious does a great job of reminding us that this isn't just theoretical stuff.
Right.
This is how our favorite tech actually works.
Yeah, it is. Let's start with something as familiar as typing a search into Google.
Okay.
What seems like a simple action is actually a beautiful interplay of these programming concepts.
All right, so when I type best pizza near me into the search bar,
Yeah.
that's my input, right?
Right. Your words are taken as input, and the search engine stores them in a variable.
Okay.
Probably something like search query.
And then what does the search engine just go off and look for pizza places?
Well, it's a bit more nuanced than that. The search engine uses that search query variable to trigger a complex series of actions,
Okay.
sifting through massive amounts of data to find websites related to pizza places near you.
So it's using my location too.
Yes, that's where algorithms come in.
Algorithms. I feel like that's a whole other deep dive waiting to happen.
It is, but in simple terms.
Okay.
Think of algorithms as sets of instructions that determine how the search engine ranks and displays results. They analyze factors like the location of the pizza, places their reviews, how often their websites are linked to by other sites,
Right.
and even your own past searches to present you with the most relevant options.
So it's not just a simple keyword match.
No.
The search engine is using my input and a ton of other data to try to figure out what I really want, even if I haven't spelled it out exactly.
Exactly. And all of this processing and analysis happens behind the scenes, thanks to variables that store and manipulate data
Okay.
and algorithms that act as the brains of the operation.
Right.
The output, of course, is the list of search results you see on your screen,
Yeah.
hopefully leading you to that perfect slice.
That's amazing.
Ah.
And it makes me think about how these same concepts are probably at work in social media, too. Like
yeah.
when I scroll through my feed and I see posts from friends and ads for things that I might actually want.
Yeah.
And, you know, those suggested for you recommendations.
You're spot on. Every comment and share you make on social media is input that's fed into algorithms. Wow. These algorithms track your behavior, analyze your interests, and use that information to personalize your experience, all through the clever manipulation of variables.
So social media platforms are essentially running giant ongoing programs
Right.
where we're all providing the input and our personalized feeds are the output.
Exactly.
Kind of mind-blowing when you think about it.
It is. And it highlights how understanding these programming concepts can give you a deeper appreciation for how technology shapes our lives, even in seemingly mundane ways.
It also makes me wonder, what else these concepts are behind. Are they just for things like search engines and social media?
No, they're everywhere.
Or do they have even broader applications?
Think about online shopping. Those customers also bought recommendations you see are driven by algorithms analyzing purchase history data stored in variables.
Oh, okay.
Or consider navigation apps that calculate the fastest route based on real-time traffic information.
Yeah.
It's all powered by the interplay of input-output variables and those clever algorithms.
So we're talking about everything from finding the best pizza
Right.
to navigating traffic to personalized shopping experiences.
Thanks for
That's
that.
all connected by these programming concepts.
It is. And as technology continues to evolve, understanding these fundamentals will become even more crucial.
Yeah.
Whether you're interacting with artificial intelligence, exploring the metaverse, or just using everyday apps, these concepts will be at the heart of it all.
This has been a really incredible deep dive.
It has.
We started with what seemed like simple ideas, but they're the foundation for so much of the technology we use every single day.
It's true. And I think the key takeaway from Code Curious and our discussion is that programming isn't some mysterious, inaccessible field.
Right.
The core concepts are surprisingly relatable, and understanding them can empower you to engage with technology in a more informed and critical way.
Exactly. So even if you never write a line of code yourself, just knowing a little bit about input-output variables and how they all work together can open up a whole new level of understanding about the digital world around us. Who knows, maybe some of you listening will even be inspired to start coding your own creations. That's it for today's deep dive. Thanks for listening.